If you're into these astronomy sleep stories, take a second to like the video and subscribe. It helps the channel a lot. And if you're listening right now, drop a quick comment telling me where you're listening from. Now turn your lights down, get comfortable, and let your mind slow down. Tonight, we're drifting into the story of Uranus. Uranus is the planet that feels like a secret, even though it's been there the whole time. It's not flashy like Jupiter, not iconic like Saturn, not close enough to feel familiar like Mars. Uranus sits out there in the cold middle distance, pale and quiet, and the more you learn about it, the stranger it becomes. Because Uranus isn't weird in one way. It's weird in the kind of way that changes your whole idea of what a planet can be. The most famous thing about Uranus is also the most unsettling in a calm, slow way. Uranus is tilted on its side. Not a little. Not casually. Uranus is essentially rolling around the sun like a planet that got knocked over and never bothered to stand back up. Its axis is tilted so extremely that for long stretches of its year, one pole points almost straight at the sun, while the other points into darkness. And since Uranus takes about 84 Earth years to orbit the sun, that means its seasons are not cute little 3-month phases. They last decades. Decades of sunlight for one hemisphere, decades of night for the other. Then the slow swap. That kind of seasonal pattern is hard to picture if you're used to Earth, where the sun rises and sets every day for everyone. On Uranus, there are times when the sun doesn't really rise and set the same way at the poles. It just hangs, low and persistent, or disappears completely. That alone makes Uranus feel like an alien world even before you talk about what it's made of. Uranus is an ice giant, like Neptune, meaning it's not mostly hydrogen like Jupiter and Saturn, and it's not rock like Earth. It's a layered world, an outer atmosphere of hydrogen and helium with methane mixed in, and that methane absorbs red light, giving Uranus its blue-green color. But below the visible atmosphere, Uranus likely transitions into a thick mantle of ices in planetary terms. Water, ammonia, methane, compressed into hot, dense fluids under crushing pressure. And deeper still, a smaller rocky core. It's not a planet you can land on. It's a planet you descend into where down means higher pressure, higher temperature, and stranger chemistry. But Uranus doesn't even need its interior to be fascinating, because its surface behavior already feels unusual. Compared to Neptune, Uranus often looks calmer. Its clouds can appear subtle. Its storms are less obvious at first glance. For a long time, Uranus was described as kind of bland, just a smooth cyan disk. But that's mostly because Uranus hides its details. When you look closer, Uranus has bands, clouds, storms, seasonal changes, and bright features that can flare up. It's not dead, it's just quieter. And that quietness makes its weirdness feel even weirder, because a planet that's tilted sideways should have extreme sunlight patterns and dramatic atmospheric behavior, yet Uranus often looks restrained, like it's keeping its weather under control. One reason could be that Uranus gives off much less internal heat than Neptune does. Both are ice giants, similar in size, but Neptune radiates more heat than it receives, while Uranus seems closer to balancing, like it doesn't leak much extra warmth. That's a huge clue about the interior. It suggests Uranus might be trapping heat inside or structured differently, maybe layered in a way that prevents heat from rising efficiently. Some scientists think Uranus may have had a massive collision early in its history, something that knocked it onto its side, and that same collision might have mixed its interior in a way that changed how heat escapes or created layers that keep heat bottled up. Whether that's the full answer or not, Uranus carries the signature of ancient violence in the calmest form, a sideways spin that never corrected itself. Uranus also has rings, not bright like Saturn's, but real thin, dark rings made mostly of larger particles and dust, discovered relatively late compared to Saturn's because they don't shine brightly. Uranus has a whole system of moons, too, with names pulled from literature, Shakespeare and Pope, giving the Uranian system a strangely poetic vibe. And those moons, like many moons in the outer solar system, can be icy and cratered and quiet, with their own subtle stories. But the moment when Uranus became real in human detail was the same kind of moment Neptune had, a spacecraft flyby. Voyager 2 visited Uranus in 1986, giving us our main close-up encounter. Voyager found a planet that looked pale and smooth, but also revealed structure in its atmosphere and confirmed the rings and moons in a way Earth-based observations couldn't. And because Uranus is tilted, Voyager happened to see it during a specific seasonal phase. One pole pointed towards the sun, meaning even our best close-up view of Uranus was biased by a particular season. That's another Uranus theme. We keep seeing it at angles that don't show the full story, and because its seasons are so long, it takes decades to watch it change meaningfully. Uranus is a planet that demands patience. You don't understand a sideways world by looking once. You understand it by watching it slowly roll through an 84-year orbit and noticing how light, heat, and clouds respond over time. So tonight, the simplest way to hold Uranus in your mind is this: a pale blue-green ice giant, quietly rolling around the sun on its side, with decades-long seasons, faint rings, literary moons, and an interior that seems to hold on to its heat like a secret. In the next part, we'll sink deeper into what that sideways tilt actually does to Uranus' sky, what day, night, and season really mean on a planet that rolls, and how that shapes its atmosphere in ways that are still being figured out. Uranus is the planet that rewires your sense of normal the moment you picture its axis, because once you really accept that it's rolling around the sun on its side, everything you assume about daylight, seasons, and weather starts to break. On Earth, even if seasons change, the daily rhythm stays familiar. The sun rises, crosses the sky, sets, and you get a night that resets your brain. On Uranus, the daily rhythm exists. The planet still rotates in about 17 hours. But the sunlight doesn't behave the same way across the planet during different parts of its long year. Uranus takes about 84 Earth years to orbit the sun. Its axial tilt is so extreme that near solstices, one hemisphere is tipped towards the sun and the other is tipped away. That means for long stretches, regions near one pole can experience continuous daylight, while regions near the opposite pole can experience continuous darkness. Not for a few days, not for a couple weeks, for years and years, decades. It's the kind of lighting pattern that feels impossible until you remember. Seasons on Uranus are half a lifetime, and that changes what season even means. A Uranian summer isn't a warm season you go outside for. It's an era where sunlight constantly skims the same hemisphere while the other waits in darkness, cold and quiet. Then, over many years, the balance shifts, and eventually the sun moves to the other side. When Uranus reaches an equinox, the sun shines more evenly across its equator, and that's when day-night cycles become more normal across the planet. But even then, normal is relative. Uranus is a world where the sun's path across the sky depends heavily on where Uranus is in its orbit. So the atmosphere has to respond to lighting conditions that are unbelievably uneven compared to Earth's. The obvious assumption is that this would create extreme atmospheric effects, massive temperature differences, dramatic storms, violent circulation as the planet tries to redistribute heat. But Uranus complicates that assumption in a way that feels almost unfair. It often looks calm. That calmness is one of Uranus's biggest mysteries. Why does a planet with such extreme seasons often appear so subdued? Part of the answer might be that Uranus receives very little sunlight overall because it's far away, so even summer sunlight isn't particularly strong. The sunlight is a weak lamp, not a furnace. Another part of the answer might be that Uranus's atmosphere and interior handle heat differently than Neptune's. Uranus seems to emit much less internal heat than Neptune, meaning its atmosphere might be driven less by internal energy and more by external sunlight and slow seasonal changes. If the atmosphere isn't being constantly pumped by internal heat, it might not build the same wild, fast-moving storms Neptune does. But that still doesn't fully explain why Uranus can be so quiet when its seasons are so extreme. The truth is, Uranus is an ice giant we still haven't watched long enough. We've seen it up close only once, and at a very specific season. Voyager 2 flew by Uranus in 1986 when Uranus was near solstice, one pole tipped toward the sun. Voyager saw a planet that looked smooth and pale, with minimal visible storm activity. For a long time, that shaped the public image of Uranus as a bland planet. But as years passed and Uranus moved toward equinox, astronomers saw more activity. More cloud features, more storms, more bands, more subtle structure. Uranus started to look more alive, more like a planet with weather rather than a quiet cyan ball. That shift suggests something important. Uranus's atmosphere might be strongly seasonal, with activity increasing as sunlight distribution changes. In other words, the calm Uranus might be partly a seasonal snapshot, not the full personality. That's why Uranus is a planet that demands patience. Its year is so long that we, as a species, have only observed parts of its seasonal cycle with modern instruments. It's like trying to understand Earth's climate by watching only 1 month. You'd miss the rhythm. You'd miss the patterns. Uranus is slow enough that it hides its behavior behind time. The side tilt also changes how you should imagine the sky. If you were floating in Uranus's upper atmosphere near one of the poles during a Uranian summer, you could have the sun hanging in the sky for years, circling slowly, never truly setting. The light would be faint, but persistent, a constant presence. During winter, that same region could go into years of darkness, lit only by starlight and the faint glow of distant planets. At the equator, the experience would change more across the orbit. Sometimes the sun would behave more like a normal day-night cycle, sometimes it would be skewed. That kind of long light, long dark cycle could create slow changes in temperature and chemistry. In Earth's atmosphere, sunlight drives chemical reactions and shapes ozone layers and hazes. On Uranus, sunlight is weaker but still important, and decades of continuous sunlight or darkness could influence haze formation, cloud condensation, and the distribution of methane and other compounds. The planet's color could even subtly shift depending on how methane and haze layers change with season, because what you see is a product of light, scattering and absorption in the upper atmosphere. So Uranus's look, its pale blue-green calm, may not be static. It may evolve slowly as the lighting angle changes. There's another detail that makes Uranus's seasons even weirder. The planet's magnetic field doesn't line up neatly with its rotation axis, and it's offset from the center too, similar to Neptune. That means as Uranus rotates, its magnetosphere wobbles and changes orientation in a complex way. Combine that with the extreme tilt, and Uranus interacts with the solar wind in unusual patterns through its year. There are times when the magnetosphere is oriented one way relative to the Sun, and times when it's very different. That could affect auroras, charged particle behavior, and even upper atmosphere chemistry over long times. Uranus is basically a planet where the geometry is always wrong in the most interesting way. The axis is sideways, the magnetic field is tilted and off-center, and the sunlight hits it at angles that feel like a mistake. But it's not a mistake. It's a history that likely includes some early event, maybe a giant impact, that tipped the planet and possibly altered its interior. When you picture Uranus rolling through space like that, it becomes less of a joke planet and more of a quiet survivor of ancient chaos. And if you're listening at night, that's a good mood to settle into. A planet carrying the memory of early violence in the form of a permanent sideways spin, now drifting in cold sunlight through seasons that last longer than most human lives, changing slowly enough that we're still learning what normal even looks like there. In the next part, we'll step deeper into Uranus's atmosphere itself, its composition, its cloud layers, why it looks paler than Neptune, and what kind of storms and winds it actually has when it decides to show them. Uranus's atmosphere is the reason the planet looks calm even when its seasons are extreme. From far away, it's this smooth blue-green disk, almost pastel compared to Neptune's deeper blue, and it's easy to assume nothing's happening. But Uranus isn't empty of weather. It's just subtle, and the subtlety is the trick. The outer atmosphere is mostly hydrogen and helium, like the other giant planets, but methane is the ingredient that changes the light. Methane absorbs red wavelengths, so more blue-green light reflects back, and that's why Uranus has that cold, minty tone. The difference between Uranus and Neptune's color isn't just aesthetics. It hints at differences in haze, methane distribution, and atmospheric chemistry. Uranus often appears paler because it may have thicker haze layers in the upper atmosphere that scatter light differently, softening contrast and washing out sharp features. A hazier sky means less dramatic texture, even if the winds are moving underneath. Think of it like looking at a distant landscape through fog. The land is still there, but the details flatten. Uranus's atmosphere can be like that, beautifully muted, hiding its structure in a veil. The cloud layers on Uranus are also not one simple sheet. The uppermost visible clouds can be methane ice clouds, forming where the temperature and pressure let methane condense into crystals. Deeper down, there may be clouds made of other compounds, like ammonia or hydrogen sulfide, depending on the exact temperature profile and chemistry. These deeper clouds aren't always visible from Earth because the upper haze can obscure them and because the planet's contrast is low. But when Uranus decides to show you something, when a storm lifts material higher, when a bright cloud forms at a higher altitude, it suddenly becomes clear that the planet has layers and motion. Observations over the years have revealed bands, jets, and storms, especially around times when the lighting geometry changes and more of the planet's atmosphere becomes visible in different ways. Uranus has winds, strong winds, not quite the headline speeds of Neptune, but still powerful. The winds move in zonal jets, east-west flows at different latitudes. Some regions move faster than others, and the direction of flow can change with latitude. Like other giant planets, Uranus's rotation helps organize these flows into bands. But again, the bands are often faint, as if the planet is keeping its weather private. When you imagine Uranus's winds, don't imagine noisy gusts. Imagine broad currents sliding around a sphere, a planetary-scale stream you could never stand against. The soundlessness of it makes it feel dreamlike. Motion without noise, power without display. Storms on Uranus are real, too. Astronomers have seen bright storm systems and cloud outbursts, features that can appear suddenly, brighten the atmosphere, and then fade. Some storms have been large enough to see clearly in high-resolution images, and some have been associated with seasonal timing, suggesting that Uranus may become more active as it approaches equinox and sunlight spreads differently across the planet. It's as if Uranus wakes up when the light changes. That idea fits the sideways tilt story perfectly. If one hemisphere has been in long darkness and then gradually returns to more balanced sunlight, the temperature gradients and chemistry shifts could change, altering how clouds form and how the winds reorganize. Uranus might not do constant obvious chaos the way Jupiter does, but it can do episodes, moments of activity that break through the haze like a thought breaking through sleep. Another key point is that Uranus seems to give off very little internal heat compared to Neptune. That matters because internal heat helps drive convection, and convection helps drive storms and strong weather patterns. On Neptune, internal heat is a major engine. On Uranus, the internal heat output appears smaller, which suggests the atmosphere might be less powered from below. This could be why Uranus's weather often appears subdued. But the reason Uranus has less obvious internal heat is itself a mystery, and it ties back to the planet's possible past. If Uranus experienced a giant impact long ago, big enough to knock it sideways, that event could have altered how the interior mixes. It might have created a layered structure where warmer material is trapped beneath a stable layer, slowing heat transport upward. If heat can't escape easily, the atmosphere gets less fuel. So Uranus's calmness might be the calmness of a planet that is thermally bottled, holding warmth deep inside like a sealed room. That's a haunting kind of calm, because it implies energy is still there, just not easily released. Uranus's atmosphere also behaves strangely in terms of composition. Methane is present, but its abundance seems to vary by latitude, and that variation affects cloud formation and color. Some studies suggest methane may be depleted at certain latitudes near the poles compared to equatorial regions, which could change how light is absorbed and scattered. That could contribute to differences in brightness and the appearance of hazes. Uranus's poles have shown interesting brightening and changing patterns over time. Because the planet is tilted, the poles receive very different sunlight conditions across the orbit, and that can influence haze production and cloud visibility. So when people say Uranus is featureless, what they often mean is that the features are low contrast and seasonally dependent. The planet can look smooth, then years later look more structured, not because it transformed into a new planet, but because the angle of light, haze thickness, and cloud patterns shifted. Uranus is one of the best examples of how perception can mislead you in astronomy. A planet can be active and still look quiet if the atmosphere hides the contrast. Even the temperature structure of Uranus is a layer of mystery. The upper atmosphere is extremely cold, among the coldest in the solar system, and that's interesting because Neptune, farther away, can have different thermal behavior in certain layers. The coldness of Uranus's upper atmosphere suggests complex energy balance, how the planet absorbs sunlight, how it emits infrared radiation, how internal heat contributes, or doesn't, and how atmospheric circulation moves energy around. It's not as simple as farther equals colder. Planetary atmospheres are complicated machines, and Uranus is a machine we've only listened to briefly. Voyager 2's flyby gave us crucial data, but it was a snapshot taken at a particular season and geometry, and we've been piecing together the rest from distant observations ever since. If you picture Uranus as a place, picture it as a layered sky where color is chemistry and motion is hidden. A pale, blue-green dome with thin hazes that soften everything. High methane clouds appearing like bright puffs or streaks. Faint bands marking different wind regimes. Occasional storms pushing material higher, making the planet's weather visible for a moment, like a secret being revealed. And beneath all of that, deep layers where pressure rises and air becomes fluid, where water, ammonia, and methane exist in hot, dense states, where the planet's magnetic field is generated by strange conducting layers rather than a neat core. Uranus isn't just cold, it's controlled. Controlled by tilt, by slow seasons, by a muted heat engine, by hazes that act like curtains. That control is why Uranus feels different from Neptune. Neptune is bold and blue with obvious drama. Uranus is subtle and pale with drama that shows itself only when conditions align. And that subtlety is actually a gift for a sleep story, because it lets your mind drift without sharp images. You can imagine Uranus as a quiet world rolling through space, its atmosphere moving steadily under a veil, its storms appearing softly and fading, its winds sliding around the globe in wide currents. In the next part, we'll shift from Uranus's sky to Uranus's hidden engines, its strange magnetic field, what makes it so different from Earth's, and what that tells us about the deep interior of an ice giant that refuses to behave normally. Uranus has a way of being strange in the most invisible places. You can stare at its pale blue-green face and see quiet clouds, faint bands, occasional storms, and still miss one of the planet's biggest oddities entirely, because it isn't something you see with your eyes. It's something you feel with instruments. Uranus has a magnetic field that behaves like it's been built by a different set of rules than Earth's, and once you understand even the basic shape of it, Uranus stops feeling like a calm planet and starts feeling like a planet with hidden machinery running off-center. On Earth, the magnetic field is fairly tidy in concept. It's roughly aligned with Earth's rotation axis, and it's generated deep in the core by moving conductive fluid, molten iron, creating a dynamo. It's not perfect, but it's fairly centered. Uranus is not like that. Uranus's magnetic field is strongly tilted relative to its rotation axis, and it's offset from the planet's center by a significant amount. That means the magnetic field is not a neat, symmetrical bubble. It's lopsided. And because Uranus is already tilted on its side, the whole geometry becomes even more bizarre. As Uranus rotates, its magnetic field swings around in space like a crooked lantern, changing orientation constantly relative to the Sun. The result is a magnetosphere that isn't stable and symmetric the way you might imagine. It's a shifting, wobbling structure that can behave in complex ways as it interacts with the solar wind. If Neptune feels like a quiet gatekeeper, Uranus feels like a gatekeeper with a crooked compass. The magnetosphere doesn't just sit there. It moves, and it moves through the solar wind differently depending on where Uranus is in its orbit and how its sideways tilt points it relative to the Sun. There are times in Uranus's year when the planet's rotational axis is pointed more toward the Sun, and times when it's pointed sideways relative to it, and in each case, the magnetosphere's orientation changes dramatically. Imagine the solar wind, charged particles flowing outward from the Sun like a constant stream, hitting a magnetic bubble that isn't facing it cleanly, but at awkward angles, sometimes almost side-on, sometimes with a pole pointed towards the flow. That interaction shapes how particles are deflected, trapped, and guided along magnetic lines, and it influences auroras and radiation belts. But the real question is, why is Uranus's magnetic field so weird? That question points straight into the planet's interior, because a magnetic field is an imprint of the dynamo region, where conductive material is moving and generating electric currents. If Uranus had a neat, molten metal core dynamo like Earth's, you'd expect a more centered and aligned field. The tilt and offset imply that the dynamo is happening in a different place, likely not at the very center, and not in a simple layer. The leading idea is that in ice giants like Uranus, the dynamo may be generated in a shell of electrically conducting fluid within the mantle, somewhere above the core, in a region where water and ammonia and other materials under pressure become ionic or conductive enough to carry electric currents. That means Uranus's magnetic engine might be sitting in a middle layer rather than the deepest center. If the conducting layer is uneven, or if the flow patterns are complex, the resulting field can become strongly tilted and offset. Uranus is basically telling us that its inside is not neatly layered and symmetric. It's irregular in the ways that matter. And that makes sense when you remember the planet's sideways tilt and the possibility of a giant impact early in its history. A huge collision could have tipped the planet and also disturbed or restructured its interior, creating layers that don't mix well or regions that generate magnetism in unusual ways. Uranus's magnetic weirdness could be a fossil of that ancient event. If you like calming imagery, picture Uranus as a planet that looks smooth and quiet on the outside, but inside it has a churning conductive ocean layer generating a magnetic field that doesn't line up with anything, like a calm face hiding an off-kilter heartbeat. Uranus also has radiation belts, zones of trapped charged particles formed by its magnetosphere. These belts can be intense, and the way they form and behave depends on the geometry of the magnetic field. Because the field is tilted and offset, the belts can be asymmetric too. Uranus's magnetosphere may trap particles in patterns that shift as the planet rotates and as the solar wind conditions change. When you add the extreme axial tilt, the system becomes even more time-dependent. It's not just Uranus has a magnetosphere, it's Uranus has a magnetosphere that changes its relationship to the Sun dramatically over its long orbit. That means auroras, those glows where charged particles crash into atmospheric molecules, can behave differently than on Earth. Uranus's auroras have been observed, but they're harder to study in detail because of distance and because the planet's geometry creates complex conditions. Still, the idea of auroras on Uranus is beautiful. A pale blue-green world with invisible magnetic lines guiding particles, causing faint glows near regions where field lines meet atmosphere. It's a reminder that even in the cold outer solar system, there's motion and energy not only in winds, but in space itself. Now here's the part that makes Uranus feel uniquely quiet compared to Neptune: the internal heat issue. Uranus emits much less excess heat than Neptune, and that suggests Uranus is not transporting internal heat upward efficiently. That could mean Uranus has a layered interior structure that suppresses convection. If convection is suppressed, you might expect the dynamo to behave differently too. The relationship between heat transport, interior mixing, and magnetic field generation is complicated, but the broad idea is simple. Uranus may be stratified, layered in composition in a way that prevents large-scale mixing. A stable layer can trap heat below and limit the movement of conductive fluids, shaping the dynamo region and potentially contributing to the weird magnetic field geometry. So Uranus's calm atmosphere, low heat output, and odd magnetism might all be connected. Not proven as one single story, but tied together as a plausible web. Uranus is a planet where the inside might be stuck in a way Neptune's isn't. Neptune leaks heat, drives storms, and shows more obvious energy. Uranus holds heat, hides contrast, and runs a magnetic engine that is crooked and off-center. That difference is one of the reasons Uranus is so valuable to study. If two similar-sized ice giants can behave so differently, then ice giants as a class are more diverse than we thought. And since Neptune-sized, planets appear common around other stars, understanding Uranus matters far beyond our solar system. Uranus is a local example of how a planet can be stable and strange at the same time. So let this part settle into a quiet image. Uranus rolling on its side through a long orbit, its pale atmosphere drifting under hazes, while deep inside a conductive layer churns and generates a magnetic field that's tilted and offset, an invisible structure sweeping space as the planet rotates. Charged particles spiral along field lines, radiation belts form, auroras flicker faintly. Everything is moving, but the movement is silent. And because the geometry is so odd, Uranus's magnetosphere never looks the same for long. It's always shifting relative to the Sun, changing its stance, like a planet that refuses to face the universe in a straight line. In the next part, we'll move outward again, away from the invisible field, and back into the visible system. Uranus's rings and moons, thin, dark, rings, shepherding interactions, and the literary named moons that orbit a planet that seems to have been knocked sideways long ago. Uranus has rings, but they don't show off. Saturn's rings are bright and obvious, like the planet wants you to notice. Uranus's rings are the opposite. Thin, dark, narrow bands that feel like they're trying to stay hidden. And that fits Uranus perfectly. because Uranus is a planet that looks quiet until you look properly. The rings were discovered in a way that also feels very Uranus, not by someone casually spotting them through a telescope, but during a stellar occultation. Astronomers watched Uranus pass in front of a star, expecting the starlight to dim once as the planet blocked it, and instead the light flickered multiple times before and after the main dip. Those flickers were the rings, slicing through the starlight like thin blades. It was a discovery made through absence, through noticing a pattern in what disappeared, which is kind of poetic for a planet that was once missed by people staring right at it. Uranus's rings are mostly dark because the particles are darker and larger than the dust-dominated reflective ice you see in Saturn's system. They're not giant, bright sheets. They're narrow lanes, sharp-edged, and surprisingly confined. When you picture them, don't picture a glowing halo. Picture graphite-thin hoops, subtle and strict, like the planet is wearing minimal jewelry in deep space. The fact that the rings are narrow matters. Narrow rings don't stay narrow by accident. Over time, particles collide and spread, and the ring should blur outward unless something is maintaining the edges. That something is usually moons. Tiny shepherd moons, hidden close by, can use gravity to confine ring particles, nudging them back into place again and again, keeping the ring sharp. It's the same idea as Neptune's arcs, but expressed differently. Gravity repeating a small correction until it becomes structure. That's the outer solar system in a nutshell. Nothing is held together by walls, only by rhythm. Uranus has multiple rings, and each one sits at its own distance, each with its own particle population and thickness. Some rings are denser and sharper, some are fainter and dustier. There are also dusty components and faint inner rings that are harder to see. But the overall vibe stays the same. A ring system that feels engineered, not because it was designed, but because physics can create clean lines when resonances and shepherding are involved. And because Uranus is tilted on its side, the rings are tilted too. Sometimes we see the rings edge on from Earth, and when that happens, they become incredibly hard to detect, almost disappearing. Other times we see them more open, like a thin oval around the planet. Even visually, Uranus's rings play the same game Uranus plays. Depending on geometry, it can look like nothing is there, and then later it reveals itself. The moons of Uranus feel like they belong to a different mood than the moons of Jupiter or Saturn. They're named after characters from Shakespeare and Alexander Pope, Miranda, Ariel, Umbriel, Titania, Oberon, names that sound like a quiet theatre stage more than a space catalogue. That naming style gives the Uranian system a soft, literary aura, but the worlds themselves can be harsh, fractured, and weird. The moons are mostly icy bodies, shaped by impacts and internal stress, and the closer you look, the more you realize Uranus's calmness doesn't extend to its moon's histories. Miranda is the one that breaks people's brains first. It's not the biggest moon, but it's the most visually shocking. A patchwork world, like someone cut different terrains out of different planets and stitched them together. Miranda has massive cliffs, huge faults, and strange regions called coronae. Oval features that look like the surface was pushed up, cracked, and partly resurfaced. Some of Miranda's cliffs are among the tallest known in the solar system, and they make Miranda feel like a world that was pulled apart and then forced to keep existing. The reason Miranda looks like that isn't fully settled in one clean sentence, but there are strong ideas. Tidal heating in the past, orbital resonances that flexed the moon and warmed its interior, allowing partial melting and resurfacing, or violent impacts that disrupted it, or a combination, ancient heating that made it active enough to reshape, followed by impacts that scarred and fractured. Miranda is the moon that reminds you. Even small worlds can have dramatic geological stories if gravity squeezes them at the right time. Then you have Ariel, which shows evidence of resurfacing too, smooth plains, ridges, valleys, suggesting past activity, possibly driven by internal heat or tidal effects. Umbriel is darker and more heavily cratered, like a moon that didn't get as much internal renewal. Titania and Oberon, the two largest, are bigger, older-looking in many places, scarred by impact craters, but also showing signs of tectonic features. Faults, canyons, suggesting their interiors may have moved and cracked the crust long ago. These moons are not just frozen rubble. They're worlds with layered histories. Formation, bombardment, flexing, cracking, resurfacing, cooling. The ring system and moon system also interact in subtle ways. Rings can be fed by moons through micrometeorite impacts that kick dust off a moon's surface and into orbit. Rings can also contain small moonlets embedded within them, or moons can shape ring edges through resonance. It's a living system in the sense that it evolves. Particles collide, dust spreads, moons nudge, arcs sharpen, material gets replenished and lost. And because everything is tilted with Uranus, the whole system rotates through an unusual geometry over the planet's long year, meaning sunlight falls on the rings and moons differently across decades. A ring particle on Uranus doesn't live in a stable lighting environment. It lives through eras of illumination and eras of shadow, depending on Uranus's orientation to the Sun. That can affect temperatures, charged particle interactions, and how dust behaves. Even the magnetosphere ties in here, because rings and moons sit inside Uranus's magnetic environment. Small grains can become electrically charged and respond to magnetic fields in subtle ways, shifting their dynamics. So Uranus's rings aren't just passive debris, they're part of a larger system shaped by gravity, collisions, and electromagnetism, all happening quietly in cold space. What makes Uranus's moons especially interesting is how little close-up time we've had with them. Voyager 2 gave us our main close look, and like everything with Uranus, it was a brief visit at a particular season. That means many surfaces were seen under specific lighting and at limited resolution, leaving huge gaps in what we know. Imagine trying to understand Earth's continents by flying past once at night, seeing only half of them. That's how incomplete our Uranian moon story still is. We have hints: Miranda's chaos, Ariel's resurfacing, Titania's faults. But we don't have the kind of long-term orbital monitoring that would tell us about active processes today, about subtle changes, about outgassing, about possible subsurface oceans, about thermal anomalies. And yes, that ocean question is real. Some models suggest the larger Uranian moons might have had, or could still have, internal layers that allow liquid water beneath ice under the right conditions, especially if antifreezes like ammonia are present. That doesn't mean they're secretly ocean worlds like Europa, but it keeps them scientifically tempting. Uranus's system is a reminder that far doesn't mean simple. It just means harder to check. So if you're settling into sleep with this part, hold the Uranian system as a quiet scene, a sideways planet with thin, dark rings like narrow hoops around a pale globe, moons with literary names circling in steady orbits, and one moon, Miranda, looking like the surface itself survived a nervous breakdown and still kept going. The rings stay confined by tiny gravitational shepherds. The moons carry old scars and old cracks. Everything moves in silence. And above it all, the sun is small, and the light is faint, and the whole system feels like it belongs to a colder, slower version of reality. Next, we'll take that system and zoom out into Uranus's bigger why again. Its origin possibilities, the giant impact idea, the heat problem, and how Uranus and Neptune ended up as siblings that look similar on paper but behave like completely different personalities in practice. Uranus and Neptune look like siblings if you only glance at the stats. Similar size. Similar category, ice giants. Similar ingredients, hydrogen and helium on the outside, ices in the mantle, a rocky core deeper down. Both have weird magnetic fields that are tilted and offset. Both have rings. Both have moons. If you were forced to guess, you'd assume they behave similarly. But they don't. The difference between Uranus and Neptune is one of the cleanest examples of how two planets can be built from the same general recipe and still come out with completely different personalities. Neptune is deeper blue and visibly active, with storms and winds that scream internal heat. Uranus is paler and often looks calm, with a sideways tilt that should create chaos, yet it often feels muted. And that difference pulls you into the most important question about Uranus. What happened to it? The first big possibility is the one everyone remembers because it explains the most obvious weirdness. Uranus might have been hit. Early in the solar system's history, things were violent. Big bodies forming, colliding, scattering. A giant impact could knock a planet off its axis, and Uranus's extreme tilt makes an ancient collision feel plausible. Not a small bump, a massive hit, something big enough to change the planet's rotation direction and angle dramatically. If that happened, Uranus's sideways roll is a scar, an orbital era bruise that never healed. But the deeper point is that an impact wouldn't only tilt the planet, it could also rearrange the interior. And Uranus's interior seems strange. Specifically, Uranus emits very little excess heat compared to Neptune. Neptune radiates more energy than it gets from sunlight, meaning it's still leaking internal heat strongly. Uranus, in contrast, seems much closer to radiative balance, as if it's not letting much internal heat escape. That's not a small detail. That's a major clue that Uranus's internal structure is different in a way that affects heat transport. One idea is that Uranus has a stable layered interior, stratification, where composition changes with depth in a way that prevents efficient convection. Convection is how a planet normally transports heat. Warm material rises, cool material sinks, and over time it moves energy outward. If Uranus's interior is layered so that lighter materials sit above heavier materials in a stable arrangement, the planet might not convect well. Heat could get trapped below, unable to rise easily through the stable layers. The planet would still have internal heat, left over from formation, from slow contraction, from radioactive decay. But it would be bottled up. That could explain why the atmosphere looks less powered than Neptune's. Less heat reaching the upper layers means less fuel for dramatic storms and powerful convection-driven weather. So Uranus's calmness could be the calmness of a planet that is thermally sealed. But why would Uranus be layered like that while Neptune isn't? That's where the impact idea becomes even more tempting. A massive collision could have mixed the planet in a messy way and then left it to settle into layers, or it could have created a situation where compositional gradients became stronger, preventing later mixing. Or maybe the impact ejected heat and altered the planet's evolution. Another possibility is that Uranus and Neptune formed in slightly different ways or places, accreting different proportions of rock, ice, and gas, leading to different internal structures that evolved differently over billions of years. Even if they formed near each other, small differences early on can snowball over time, especially when the planets are largely fluid and sensitive to how heat moves. There's also the migration story. Many models suggest the giant planets shifted positions early on as they interacted with a disk of planetesimals. Neptune likely moved outward, shaping the Kuiper belt. Uranus may have migrated too. Migration can be chaotic. Planets can experience resonant interactions, orbital instabilities, close encounters, and energy exchanges. Uranus might have had a different sequence of encounters than Neptune did. Different encounters could mean different impacts, different mixing histories, different internal heat retention. Uranus might be the ice giant that got stuck with the wrong interior layering after the early chaos settled. Neptune might be the one that kept mixing and leaking heat. What's fascinating is that Uranus's sideways tilt and low heat output might be connected, but it's not fully proven in one neat sentence. It's more like a strong suspicion. Uranus looks like a planet that suffered a major event and never fully returned to a simple state. The tilt is obvious. The heat issue is subtle. Together, they form a personality. Uranus is a planet with a dramatic external geometry and a restrained external expression. It's like a world that had something happen to it long ago and now carries the consequences quietly. Uranus's magnetic field fits into this too. Like Neptune, Uranus has a magnetic field that is tilted and offset from the center, implying the dynamo region is likely not a neat core like Earth's, but a conducting layer in the mantle, where ice materials become electrically active under pressure. If Uranus is layered and convection is suppressed, the dynamo could behave differently as well. The magnetic field's geometry suggests complex internal flows rather than one clean global circulation. That matches the idea of an interior that isn't well mixed. So again, multiple weird features might be different faces of the same deep truth. Uranus is structured in a way that prevents neat behavior. Even the atmosphere might reflect this. Uranus can look smooth and hazy, but when it does show storms and cloud features, it suggests the atmosphere can still move energetically under the right conditions, especially as seasonal lighting changes. That means Uranus might not be calm so much as slow to reveal. Its weather might be driven more by sunlight cycles than by internal heat, making it appear more seasonally modulated and less consistently active than Neptune. Neptune is like a planet that's always humming with internal energy. Uranus is like a planet that changes mood with the long year light, shifting slowly, showing its weather more when conditions push it. The sideways tilt also complicates how heat is distributed. Imagine decades of sunlight focused on one hemisphere. That can create long-term atmospheric gradients, and the planet may respond with circulation patterns that redistribute energy in ways we don't fully understand. The problem is, we haven't watched Uranus through enough of its long seasonal cycle with close-range instruments. We've seen it change in telescopes, yes, but not with the kind of detail you'd get from an orbiter. Uranus is a planet where the best explanations still have room for doubt because the data is incomplete. And that incompleteness is the point. Uranus is the ice giant that remains the most emotionally mysterious because it doesn't give obvious answers. Neptune is loud in its activity and heat. Uranus is quiet, tilted, and internally stingy with its warmth. The difference begs for a mission designed to answer it. An orbiter with an atmospheric probe could measure composition, temperature profiles, winds at different depths, and gravitational fields to infer internal layering. It could map the magnetic field in detail and track how the magnetosphere behaves through rotation and seasonal geometry. It could watch storms form and fade. It could observe rings and moons long enough to understand their dynamics. Uranus might be the best place to learn why ice giants don't all behave the same, even when they look similar at first glance. So let this part settle into a calm conclusion. Uranus is likely the result of an ancient story written in physics, possibly a giant impact, likely an unusual interior structure, a planet rolling on its side through decades-long seasons, quietly holding onto its heat, running a crooked magnetic engine, and revealing its weather only when the slow light cycle encourages it. Uranus is the sibling that looks similar but acts different, and that difference is exactly why it matters. Next, we'll lean into what a future Uranus mission would really aim to learn, what we still don't know, what questions are most important, and why Uranus might be one of the most underrated destinations for understanding planets across the galaxy. Uranus is one of the most underexplored major planets, and that's not an opinion, it's just the reality. We've had one brief flyby, and then decades of watching from far away. That's like trying to understand a whole person after seeing one photo and hearing one rumor. If you want Uranus in full, you need time near it. And that's why the idea of a dedicated Uranus mission keeps coming back. Not because it sounds cool, but because Uranus is an ice giant, and ice giants seem common in the galaxy. If we don't understand the ice giant in our own backyard, we're guessing about an entire class of worlds around other stars. A proper Uranus mission would aim at one main thing: explain why Uranus is the way it is. And to do that, it would need to answer several big questions that all connect. First, the heat problem. Uranus doesn't emit much extra heat. Is the heat truly missing, or is it trapped? Is Uranus's interior layered in a way that prevents convection? Is there a stable compositional gradient that locks warmer material below? An atmospheric probe dropping into Uranus could directly measure composition. How much methane, ammonia, water-derived compounds, and heavier elements exist in the upper atmosphere? And that would give a stronger clue to formation history. Meanwhile, an orbiter could measure gravity in detail to infer how mass is distributed inside. Gravity mapping is basically interior X-ray vision. If the planet is layered, or if there are density differences, the gravity field carries that signature. Combine probe data and gravity data, and you start turning maybe into likely. Second, the magnetic field. Uranus's magnetism is tilted and offset, implying a dynamo region that's not neat and centered. An orbiter could map the magnetic field over time and space, watching how it changes with Uranus's rotation. That would help identify where the dynamo is likely operating and what kind of internal flow patterns are needed to create such a field. It would also let scientists study Uranus's magnetosphere as a system, how it interacts with solar wind, how radiation belts form, how auroras behave, and how charged particles interact with rings and moons. Because Uranus's sideways tilt makes the geometry insane, watching its magnetosphere over time would be like watching a weather system in space. Variable, shifting, and fundamentally different, depending on Uranus's orientation to the Sun. Third, the atmosphere itself. We still don't fully understand Uranus's winds at different depths. We see cloud motions in the upper atmosphere, but that's like judging an ocean current by looking at a few pieces of foam. An orbiter with good instruments could track winds more precisely, measure temperature profiles, and observe how cloud patterns evolve with seasonal lighting. It could answer whether Uranus becomes more stormy near equinox, how methane varies by latitude, and how haze layers form and change. It could also clarify why Uranus looks paler than Neptune, whether it's mostly haze differences, methane distribution, or something deeper in atmospheric circulation. This matters because the atmosphere is the only surface we can observe, and it's how Uranus communicates its internal energy and chemistry. Fourth, the rings. Uranus's rings are narrow, dark, and sharply confined, which means something is maintaining them. An orbiter could image the rings at high resolution, study particle sizes and composition, and directly identify which moons or moonlets are shepherding them. It could also watch how the rings change, how dust is created and lost, and how electromagnetic forces might affect fine particles. Rings are not static decorations, they're dynamic systems that reveal ongoing processes, collisions, impacts, gravitational shaping. The more you learn about rings, the more you learn about the environment around the planet. Fifth, the moons. Uranus's moons are a big deal, especially because some of them show evidence of past resurfacing and internal activity. Miranda is the obvious standout with its patchwork terrain and huge cliffs, but Ariel and others also have hints of geological stories. With better mapping, we could learn whether any of these moons might still have internal heat or even subsurface layers that could allow liquid water under certain conditions. That's not guaranteed at all, but it's possible enough to matter. And even if none are active today, their geology preserves history. The history of tidal heating, orbital resonances, impacts, and internal evolution. Understanding the moons also helps understand Uranus itself, because moons and planet can exchange energy through tides and resonances, shaping each other over time. So a Uranus mission wouldn't be just for pretty pictures. It would be for the physics story. Why the planet is tilted, why it's cold and heat-stingy, why its magnetosphere is crooked, why its atmosphere is subtle, and how its rings and moons fit into that. And there's an even broader reason, the formation of planets. Uranus and Neptune are the best local examples we have for a class of planets that seems extremely common in exoplanet surveys, Neptune-sized worlds. But we've never fully understood their interiors, because you can't just look at an ice giant and know how it formed. You need composition, you need structure, you need heat flow, you need magnetic field behavior. Uranus is like a textbook that we only read the cover of. If we read the whole book, we'd improve our ability to interpret Neptune-like exoplanets, worlds where we often only know radius and mass and maybe atmospheric hints. Uranus is a calibration point for the galaxy. It's also a perfect planet for a sleep story because the mission concept itself is slow. It would take years to travel there. It would arrive at a world where seasons last decades. It would orbit a planet that rotates in 17 hours and rolls sideways through an 84-year year. It would watch changes that don't happen in a day but in months and years. It would turn Uranus into a long observation rather than a quick visit. And that is exactly what Uranus needs. If you imagine a spacecraft approaching Uranus, you can picture the planet growing in the window. Pale blue-green, faint banding. Thin rings slicing around it like dark lines, moons hanging nearby like quiet companions. Instruments begin to map the magnetic field. A probe detaches and falls into the atmosphere, sending back numbers that become the first true taste of Uranus's composition at depth. The orbiter circles, watching storms brighten and fade, watching haze layers shift, watching sunlight angle change across time. Miranda comes into view, its broken terrain mapped in detail. Ariel's surfaces reveal their old cracks and flows. The rings become a living structure rather than a thin line. The magnetosphere becomes a dynamic system rather than a single measurement. And little by little, Uranus becomes less like a mystery and more like a world you actually understand. That's the calm truth. Uranus isn't unknowable. It's underwatched. It's a planet that requires patience and proximity. It's a planet where the biggest secrets aren't loud, they're structural. So if you're drifting off, let this part settle as a simple idea. Uranus is one of the most important planets we haven't properly studied, and the day we do, it will likely explain not just Uranus, but the entire category of ice giants, including the ones around other stars. Next, we'll take the emotional step back and tie Uranus into a final mood, how all its weird traits connect into one identity, and why a sideways, quiet, pale planet might be one of the most uniquely calming worlds to fall asleep thinking about. Uranus is the kind of planet that doesn't grab you with one dramatic headline. It gets under your skin slowly. The sideways tilt is the obvious hook, but once you sit with it, you realize everything about Uranus feels like the consequence of that one ancient imbalance. It's a world that seems permanently off-kilter, not in a chaotic way, but in a calm, stubborn way, as if the planet accepted its strange posture and kept going. And that makes Uranus feel uniquely peaceful to think about, because it turns extreme weirdness into steady routine. A planet rolling on its side shouldn't feel stable, but Uranus makes it feel normal, simply by doing it for billions of years. When you imagine Uranus, start with the light. The sun out there is smaller, weaker, and it doesn't behave the way you're used to. Decades of sunlight on one hemisphere, decades of darkness on the other. Then a slow swap that takes years to notice. That kind of lighting creates a planet that lives in long moods, instead of daily swings. On Earth, your body understands day and night like a heartbeat. On Uranus, the heartbeat is stretched. Long, bright phases, long, dark phases, and transitions that feel like slow breathing. It's not warm or cozy, but it's steady, and steadiness is what your brain wants when you're trying to fall asleep. Uranus's atmosphere matches that mood. It's pale blue-green, softened by hazes that flatten contrast and make the planet look smooth. The smoothness isn't emptiness, it's a veil. Under the veil are winds and bands and clouds, but Uranus doesn't display them like a show. It hides them, reveals them, then hides them again. Sometimes storms brighten, and you catch a glimpse of the planet's activity. Sometimes it looks quiet for years. That subtlety makes Uranus feel like a planet that speaks in whispers. Neptune is the ice giant that flexes its strength with fast winds and dramatic storms. Uranus is the ice giant that keeps its strength internal, locked behind haze, releasing just enough weather to prove it's alive, but not enough to make itself obvious. That held-back vibe connects directly to Uranus's heat mystery. Uranus doesn't radiate much extra heat compared to Neptune, which suggests it either lost internal heat early or traps it behind stable layers that prevent convection. Either way, Uranus feels like a planet that doesn't like letting its energy escape. A sealed world. And that might be the most Uranus trait of all. It's tilted, it's weird, it's clearly not normal, yet it's restrained. It doesn't blow its secrets into space. It keeps them. Even its magnetic field, which is one of the strangest things about it, is invisible unless you come close with instruments. It's tilted, offset, and lopsided, generating a magnetosphere that wobbles as the planet rotates. If Earth's magnetic field feels like a centered shield, Uranus's feels like a shield that's been shoved to the side, still working, still protecting, but doing it in a weird stance. And because Uranus is already on its side, its magnetosphere meets the solar wind in awkward, changing orientations across its long year. That means even the space around Uranus is dynamic in a way that's hard to picture. Fields and particles moving in a shifting geometry, auroras flickering under strange conditions, radiation belts forming in patterns that aren't symmetrical. It's a planet with invisible motion layered on top of visible motion, and both are shaped by wrong angles that became permanent. Then you step outward from the planet's pale face, and you find the rings, thin, dark, narrow bands that were discovered by watching starlight blink, not by seeing a bright halo. Again, Uranus reveals itself through subtlety. Its rings are confining themselves in sharp lanes, likely held by tiny moons and resonances that keep edges crisp. And around those rings are moons with names that sound like a poem. Miranda, Ariel, Umbriel, Titania, Oberon. The names make the system feel gentle, but the geology can be brutal. Miranda especially looks like a world that got broken and stitched back together. Towering cliffs, fractured terrain, bizarre patchwork regions. It's another quiet echo of the same theme. Uranus's system doesn't look like it lived a peaceful childhood. Something happened. Something tilted the planet, and the aftermath left fingerprints across the entire system. And yet, despite all of that, Uranus today feels calm. That's the part that makes it so good for a sleep story. Uranus is a survivor, a world that might have been slammed by ancient violence, knocked sideways, internally rearranged, and still it became stable enough to roll through space for billions of years with its rings intact, its moons orbiting, its hazes drifting, its seasons stretching across generations. That steadiness is the comfort. It tells you that even the most extreme changes can settle into a rhythm. Not a perfect rhythm, not a normal rhythm, but a rhythm that holds. So if you're winding down, let Uranus be the image of strange stability. A pale planet rolling on its side under a small, distant sun, living through decades of light and decades of dark, moving its clouds quietly under hazes, holding its heat deeper down, running an off-center magnetic engine, wearing thin dark rings like narrow hoops, and keeping a family of literary moons circling in silence. Uranus doesn't need to be loud to be powerful. It doesn't need to be bright to matter. It's an off-kilter world that turned weirdness into routine, and if you let that idea settle, it can do the same thing for your thoughts. Take whatever's been buzzing in your head and stretch it out, soften it, and let it drift into something quieter. Uranus is a planet that stays underrated because people treat it like a punchline, and that's honestly trash thinking. If you actually look at what Uranus is, it's one of the cleanest reminders that the solar system didn't form politely. Uranus is a fossil of early chaos, frozen into a steady rhythm, rolling through space with a sideways spin that shouldn't exist unless something big happened. And the more you connect the pieces, the more Uranus feels like a single identity instead of a list of weird facts. Start with the tilt, because the tilt is the spine of the whole story. Uranus doesn't just lean, it lies almost sideways, and that turns seasons into decades-long eras. One hemisphere can sit in weak sunlight for years, while the other sinks into long darkness. Then they trade places slowly over an 84-year orbit. That alone forces the atmosphere to behave on time, scales humans don't naturally understand. It also means our understanding of Uranus is biased by timing. We've only watched parts of its seasonal cycle with modern tools, and our only close flyby happened during a specific seasonal setup. So every Uranus is calm take is automatically suspect. Calm compared to what? Calm during which season? Uranus is slow enough to make people confuse "I didn't see it" with "it isn't happening." The atmosphere follows the same theme. Subtlety. Uranus looks pale blue-green because methane shapes the light and hazes soften the contrast. Those hazes act like curtains. They don't mean nothing is moving. They mean the moving parts are harder to see. When Uranus does show activity, bright clouds, storms, banding, those moments prove the planet has real weather and real winds, just not always in a loud, high-contrast way. It's a planet that hides its motion behind chemistry. And then the heat problem sits underneath all of it like a locked door. Uranus doesn't radiate much extra heat compared to Neptune, which suggests its interior isn't transporting warmth upward efficiently. That likely means layering, stratification, a stable internal structure that suppresses convection and traps energy deeper down. If that's true, Uranus isn't cold because it's far. It's cold-looking because it's internally stingy. Heat is there, but the planet keeps it contained. That one feature could explain a lot. Why the atmosphere looks less consistently stormy than Neptune's, why the planet's outer layers feel restrained, and why Uranus has this muted personality compared to its sibling. The magnetic field fits the same pattern, weird and off-center. Uranus's magnetic field is tilted and offset, implying the dynamo isn't a neat central core like Earth's. It's likely being generated in a conductive layer within the mantle, an interior ocean of hot, dense, electrically active fluid where water-ammonia mixtures under pressure behave in alien ways. A lopsided dynamo makes a lopsided field. Combine that with Uranus being sideways, and the magnetosphere becomes this constantly shifting structure relative to the Sun, which means even the space around Uranus has its own restless geometry. You just don't notice it unless you're there with instruments. Again, hidden motion. Then you step outward and you get rings that match the personality perfectly. Thin, dark, narrow, sharply confined. Not bright and showy, but precise, held in place by gravity and shepherding like the planet doesn't allow mess. And circling within that system are moons with names that sound gentle, Shakespearean, poetic, but with surfaces that tell harsher stories. Miranda is the loudest example. Fractured, patchwork terrain, enormous cliffs, a moon that looks like it was stressed and rebuilt. That suggests the Uranian system isn't just quietly sitting there. It has a history of heating, resonances, impacts, and internal strain. The calm you see now is the calm after a long settling, not the calm of a planet that never went through anything. And that's the final connection that makes Uranus feel whole. Uranus is a planet where extreme doesn't look extreme. The extremeness is in geometry, in long time scales, in interior structure, in invisible fields, in subtle rings, in muted clouds. It's a planet that carries huge weirdness, but expresses it softly. That's why it's such a good subject to drift off to, because it pulls you away from sharp, loud thoughts and into slow, quiet systems. A sideways world living in decades-long seasons, a pale atmosphere moving under hazes, a deep interior holding heat like a secret, a crooked magnetic engine sweeping space, thin dark rings held tight, moons orbiting like quiet witnesses to an old violent past. Uranus isn't boring. People are just lazy about paying attention. And if you let yourself actually pay attention for a minute, the planet becomes one of the most calming kinds of strange. Strange that's stable, strange that's patient, strange that doesn't need to prove itself. Uranus is the kind of planet that makes you realize how small your normal really is. Because once you've sat with it long enough, you stop thinking of it as a weird trivia fact, the planet on its side, and you start thinking of it as a whole world that built an entire life around being off balance. That's the final mood to end on. Uranus isn't broken. Uranus is adapted. It took something extreme, something ancient, and turned it into routine. And that routine is exactly what makes it calming to imagine while your thoughts slow down. Picture Uranus out there under a small, distant sun, not shining bright, not demanding attention, just existing in a cold, blue-green quiet. It rotates in a day that's shorter than Earth's, but its year stretches to 84 Earth years, so its seasons are not seasons, they're eras. Decades of light leaning toward one hemisphere, decades of darkness on the other. Slow transitions that don't feel like change, they feel like drifting. And somewhere inside that sideways rhythm, the atmosphere keeps moving. Winds sliding in wide bands, clouds forming and fading, storms appearing when conditions line up, and then softening back into the haze. The planet's pale color isn't a sign of emptiness. It's chemistry and haze and distance shaping what you're allowed to see. It's a reminder that there can be a lot happening behind a soft-looking surface. Deeper down, Uranus keeps its biggest secret, heat that doesn't easily escape. A planet that likely has energy inside, leftover warmth from its birth, but structured in a way that traps it. Layered, stable, restrained. That restraint shapes the whole personality. It's the difference between a world that constantly vents energy into obvious storms and a world that holds onto its energy and shows you only hints. And then beneath even that is the strange magnetic engine, tilted, offset, generated in a deep conductive layer that doesn't sit neatly at the center. Uranus's magnetosphere wobbles around it as it spins, meeting the solar wind at awkward angles across its long orbit. Invisible motion layered over visible motion, all because Uranus refuses to line up with anything the way you expect a planet to line up. Around the planet, the rings add one more quiet signature. Thin, dark, narrow bands, sharply confined, maintained by gravity and shepherding like the system prefers precision over spectacle. And orbiting beyond, the moons keep their literary names while carrying rough histories in their surfaces. Miranda's fractured patchwork, Ariel's hints of past resurfacing, the larger moons scarred by impacts and cracked by stress. The whole Uranian system feels like a stage set under faint light. Everything moving, everything silent, everything steady. And that steadiness is the point. Uranus is proof that even after violence, after whatever tilted it sideways, systems can settle. They can find balance in a new position. They can keep going without needing to fix themselves back into what we'd call normal. So if you're ending the story here, let Uranus be your last image. A pale, sideways planet rolling through deep space, living through decades-long light and dark, hiding motion behind haze, holding heat deep inside, sweeping space with a crooked magnetic field, wearing thin, dark rings like quiet lines, and carrying moons that orbit like calm witnesses. Nothing rushes, nothing demands, everything continues. And that's what you borrow from Uranus tonight. The permission to slow down, let the noise fade, and drift into something quieter. Uranus is still one of the best examples of how the solar system can look polite from far away while hiding a completely unnatural setup underneath. And the longer you sit with that, the more it stops feeling like a weird planet and starts feeling like a lesson. Reality doesn't care what you expect. It only cares what's stable over time. Uranus shouldn't be rolling on its side, and yet it does. Smoothly, patiently, like it's been doing it forever. Because it has. And that sideways spin doesn't just create a fun fact, it creates a different kind of world rhythm, where light doesn't behave like a daily comfort, but like a long, slow tide. Years of weak sun clinging to one hemisphere, years of darkness settling into the other. Then the gradual swap. Not like a switch flipping, but like a shadow moving across a room so slowly you only notice it after it's already changed. In that slow tide, the atmosphere moves under a veil, muted not because it's empty, but because hazes soften the contrast and make motion harder to read, the way fog makes a city feel quiet even when traffic is still rushing somewhere below. Uranus's winds still slide around the planet in broad bands. Its clouds still form, brighten, and fade. And when it decides to show a storm, it's like the planet briefly pulls the curtain back just to remind you there's a living system underneath the calm face. But the real personality of Uranus isn't the clouds you can see. It's the restraint you can't. The heat issue is the quiet anchor. Uranus doesn't leak much extra internal warmth the way Neptune does, which hints at an interior that may be layered in a way that traps energy, limiting convection, holding the deep warmth down where it can't easily reach the upper atmosphere. If that's true, Uranus isn't a dead world, it's a contained one. A planet that keeps its engine deeper, sealed behind stable layers, like a house with the lights on in one room and the doors closed. And then there's the magnetic field, tilted, offset, wrong in the most elegant way, generated not by a neat, centered core like Earth's, but likely by a deep conductive region in the mantle, where pressured ice behaves like an electrically active fluid. That crooked field builds a magnetosphere that wobbles and shifts as Uranus rotates, and because the whole planet is sideways, that magnetosphere meets the solar wind in changing orientations over the long year, making space around Uranus feel like it has its own weather patterns, invisible currents of particles and fields moving through a geometry that never lines up cleanly. Around it all, thin dark rings stay sharp and narrow, not bright enough to scream for attention, but precise enough to prove something is maintaining them. Small moons and resonances nudging dust into lanes, gravity repeating tiny corrections until structure holds. And those moons themselves, with their soft literary names, carry rough surfaces, and old stress, especially Miranda, which looks like it was fractured and reassembled. A small world with cliffs and patchwork terrain that hints the Uranian system had its own era of strain, resonances, heating, impacts, before settling into the quiet dance we see now. Put all of that together, and Uranus becomes less like a planet we don't talk about, and more like a planet that doesn't perform for you. It's strange, but it doesn't show off. It's extreme, but it expresses that extremeness softly. Through decades-long seasons, subtle clouds, hidden heat, tilted magnetism, narrow rings, and moons that keep scars without making a scene. If you're letting your mind slow down, that's the best thing to borrow from Uranus. The idea that you don't have to be loud to be real, and you don't have to be solved tonight to be understood enough. Just picture it one last time as a calm, sideways world under a small, distant sun, pale blue-green in the dark, drifting through, long eras of light and shadow, turning steadily, keeping its secrets deep, and letting everything above, clouds, rings, moons, move in quiet, repeating rhythm until your thoughts start matching that rhythm and finally ease into sleep. Uranus gets even stranger the moment you stop thinking of it as a surface and start thinking of it as depth, because Uranus doesn't have a ground you can stand on. It has layers you fall through, and the deeper you imagine going, the more the planet turns into a lesson about matter changing its rules under pressure. From far away it looks gentle, pale blue-green, smooth, almost shy. But that calm face is just the highest visible part of an atmosphere that thickens steadily until air becomes something closer to fluid. Up in the upper layers, it's mostly hydrogen and helium with methane mixed in. And methane is the reason the planet steals red light and leaves you that cold blue-green tone. But the other reason Uranus looks so muted is haze, thin chemical smogs in the upper atmosphere that scatter light and wash out contrast, making the planet look quiet even when winds are sliding around the globe. Bright clouds can appear, often methane ice clouds at higher altitude, and those clouds are like brief confessions, little flashes that let you track motion and prove the planet is alive. But even those are not the main story, because the main story is what happens when you go down. The light fades quickly in your imagination, not because the sun turns off, but because the atmosphere above becomes thicker and thicker, and the sunlight is weak out there to begin with, a small, distant lamp rather than a warm presence. As you descend, pressure starts to build with relentless patience. There's no dramatic, now you're inside the planet moment. There's no boundary. There's only compression, and with compression comes heat, because squeezing gas turns it warmer and deeper. Still, the chemistry becomes less like weather and more like a high-pressure laboratory. The substances we casually call ices when talking about ice giants, water, ammonia, methane, stop meaning frozen and start meaning volatile materials that, under enough pressure and temperature, become hot, dense fluids with properties that don't match everyday intuition. This is where Uranus becomes alien in the quietest way possible, not with explosions or monsters, but with the universe calmly transforming familiar molecules into unfamiliar states, because physics doesn't care what humans find comfortable. Somewhere in those deep layers, water and ammonia mixtures may become ionic and electrically conductive. And that matters because Uranus has a magnetic field that behaves like it was generated by something crooked. Unlike Earth's relatively centered, more aligned field, Uranus's magnetic field is strongly tilted relative to its rotation axis and also offset from the center, which implies the dynamo, the region creating the field, probably isn't a neat, central molten iron core like ours. Instead, the best idea is that the dynamo happens in a shell of conducting fluid inside the mantle, an interior ocean-like region where pressured ice fluids carry electric currents. If that conducting region is asymmetric, or if the flows are complicated, the magnetic field comes out lopsided, tilted, and offset, and that's exactly what we see. Uranus is a planet with a working magnetic engine that refuses to line up properly, like a compass that still points, just not the way you expect. And because Uranus itself is tilted on its side, that magnetism creates an even weirder consequence. The magnetosphere, the magnetic bubble around the planet, doesn't face the solar wind in a stable, straightforward way. The whole system rotates and wobbles, changing its orientation as Uranus spins through its short day, and changing its broader geometry as Uranus crawls through its 84-year orbit. The space around Uranus is not empty quiet. It's structured, dynamic, and electrically alive in patterns you can't see with eyes, only with instruments. Charged particles can be trapped in radiation belts, guided along magnetic field lines, and driven into the upper atmosphere where they can create auroras. Even the emptiness is in motion there. But the most haunting part of Uranus's deep story is the heat problem, because this is where Uranus starts feeling like a planet that keeps secrets on purpose. Neptune, which is similar in size and category, radiates noticeably more internal heat than it receives from the Sun, meaning it's still leaking energy from inside, which helps drive active weather. Uranus, in contrast, emits far less excess heat. That difference is enormous. It suggests Uranus isn't transporting internal warmth upward efficiently, as if the planet is thermally bottled. One leading idea is that Uranus might be stratified inside, layered by composition in a stable arrangement that suppresses convection. Convection is how planets usually move heat outward. Warm material rises, cool material sinks, and the cycle carries energy upward over time. If Uranus has a stable compositional gradient, like heavier material below and lighter above arranged in a way that resists mixing, then large-scale convection could be reduced. The heat can still exist, but it can't travel easily. It stays down. The outer layers become less fueled. The atmosphere becomes less constantly energized from below. That could help explain Uranus's muted appearance, the way it can look smooth and subdued for long stretches, then reveal storms and features when conditions and seasons line up, as if it only shows its energy when forced by slow sunlight patterns rather than constantly venting it. If Uranus is holding heat deep inside, it isn't dead. It's contained. And that containment fits the planet's entire vibe, extreme weirdness expressed softly. The sideways tilt is the loudest fact, but even that produces a slow world effect rather than a violent one. Uranus's tilt makes its seasons last decades, meaning sunlight distribution changes on a generational schedule. For years, one hemisphere can be tipped toward the sun while the other sits in darkness. Then over long time, the balance shifts. That kind of forcing can change upper atmosphere chemistry, haze production, and cloud formation slowly. Not like flipping a switch, but like the planet breathing. If the upper atmosphere spends years under weak but continuous sunlight, photochemical reactions can slowly build hazes. If it spends years in darkness, different chemistry dominates. Over time, that can change the planet's brightness patterns, especially near the poles. So even the way Uranus looks can evolve across decades, and because its year is so long, humans are always tempted to interpret short-term observations as the truth, when they're really just one phase in a larger cycle. Uranus punishes impatience. It demands that you accept partial views. That's also true of its rings and moons, which sit like quiet punctuation marks around the planet. Uranus has rings, but they're thin, dark, narrow, not bright, like Saturn's, and that's not because they're unimportant. It's because the particle composition and sizes make them less reflective, and because the system is physically confined in a disciplined way. Narrow rings don't stay narrow by accident. Particles collide and spread over time unless something keeps the edges sharp, and that something is gravity. Often shepherd moons and resonances nudging particles back into place repeatedly. That's a theme that keeps repeating at Uranus. Structure created not by walls, but by rhythm. Even the rings reflect Uranus's personality. Present but understated. Real but easy to miss. Precise rather than showy. And then the moons orbit with names pulled from Shakespeare and Pope. Miranda, Ariel, Umbriel, Titania, Oberon, names that sound gentle and theatrical, like characters waiting in dim light. But the moons themselves carry rough histories. Miranda is the standout because it looks like a broken world that kept existing anyway. Patchwork terrain, huge cliffs, strange oval regions, and fractures that suggest intense stress and a complicated past. That kind of geology hints at ancient heating episodes, maybe driven by tidal forces and resonances, where flexing warmed the interior enough to reshape the surface, followed by impacts and cooling that left scars behind. Ariel shows signs of resurfacing too, suggesting it wasn't always a cold, inert ball. The larger moons show craters, faults, and fractures, evidence of long, slow evolution. These are not decorations, they're records. They preserve hints of the Uranian system's earlier chapters, when orbits shifted, tides flexed, impacts struck, and internal heat may have mattered more. If Uranus's sideways tilt came from a huge ancient impact, that event could have influenced everything. It could have knocked the planet over, altered internal layering, changed how heat escapes, disturbed the satellite system, maybe even helped shape the rings. That doesn't mean one impact explains everything perfectly, but it's the kind of story Uranus invites. A planet that looks calm now, but carries the imprint of early chaos in its permanent posture and its restrained energy flow. And the reason all this feels so suited to sleep is because Uranus turns dramatic physics into quiet continuity. It's extreme without being frantic. It's bizarre without being loud. It's a world that took a strange configuration and made it stable for billions of years. And that's the last emotional note worth holding. Stability doesn't require normal. Uranus doesn't correct itself back to what humans would call sensible. It just keeps rolling on its side, letting decades of light and darkness trade places, letting hazes drift and soften the planet's face, letting winds slide around the globe in broad currents, letting its crooked magnetic engine sweep space in invisible patterns, letting thin dark rings hold their narrow lanes, letting literary moons circle like quiet witnesses. So if you want a final image to sink into, keep it simple but honest. Picture Uranus out in the cold, pale and calm under a small, distant sun, tilted sideways like an ancient decision that can't be undone. A planet of depth rather than surface, of hidden heat rather than obvious fire, of subtle clouds and slow seasons, of off-center magnetism and disciplined rings, of moons with soft names and hard scars, everything moving without noise, everything continuing without urgency, until your thoughts stop trying to force sharp clarity and instead do what Uranus does best: drift, settle, and keep going quietly into the dark. Uranus is the planet that makes you confront a brutal truth about how humans know things. We act like we understand worlds we've barely met. One flyby, a handful of fuzzy long-distance observations, a few decades of data on a planet whose seasons last decades and whose year lasts 84 years. That's not understanding. That's guessing with confidence. And Uranus punishes confidence because Uranus is the definition of a world where the headline fact is only the doorway. Everyone remembers the sideways tilt, but the tilt is just the most visible symptom of a deeper story. Uranus is a planet shaped by geometry, time, and hidden structure, and it behaves like a world that settled into a strange posture after early chaos and never returned to anything normal. If you want Part 414 to feel like a new layer instead of a repeat, this is the layer. What Uranus means beyond itself, why it matters for the rest of the solar system, and why it matters for planets around other stars, and why the quiet weirdness of Uranus is one of the most important kinds of weirdness we can study. Because across the galaxy, one of the most common planet sizes we detect is roughly in the Neptune to Uranus range. Not Earth-like, not Jupiter-like, ice giant-like. And that's wild because our own ice giants are the least personally familiar worlds we have among the major planets. We talk about Mars like it's a destination, We talk about Jupiter and Saturn like they're iconic, but Uranus and Neptune, the class of planet the galaxy seems to love, are the ones we've basically ignored. So when people stare at an exoplanet transit curve and say, "This is a Neptune-like world," there's a hidden problem. We don't even fully understand what Neptune-like means, and we understand Uranus-like even less. Uranus is the quiet calibration point for a massive chunk of planetary reality. And right now, our calibration is half-blind. That's why Uranus isn't a joke. It's a missing page in the instruction manual. To interpret distant worlds, you need to understand how composition, heat transport, and internal structure shape the outside. You need to know what an ice giant looks like when it's heat-rich versus heat-poor, when it's well-mixed versus stratified, when its atmosphere is haze-heavy versus haze-light, when its magnetic field is neat versus crooked. Uranus is basically a controlled experiment the solar system hands us. Same rough category as Neptune, but wildly different behavior. Two similar-sized siblings, different personalities. That difference is the key, because it proves the class isn't uniform. If Uranus and Neptune can diverge that much, then the Neptune-sized exoplanets out there could represent a whole zoo of internal structures and histories, not one simple type. Some might be heat leakers like Neptune. Some might be heat trappers like Uranus. Some might have thick hazes that flatten their appearance. Some might have clearer atmospheres with sharper features. Some might have violent weather driven by internal energy. Some might be more seasonally controlled. Some might have magnetic fields that produce weird space environments. If you don't understand Uranus, you don't just miss Uranus, you misread a big category of the universe. And the reason Uranus is the perfect planet to teach this lesson is that it hides its causes. The atmosphere is subtle, so you don't get easy visual clues. The heat problem is deep, so you can't solve it with a photograph. The magnetic field is invisible, so you need instruments near the planet to map it properly. The seasons are long, so you need patience across decades. Uranus makes you earn the answer. It's a planet that refuses to be understood by vibes. It demands measurement. Now connect that back to the solar system's early history. Uranus likely didn't form exactly in the stable, calm arrangement we see today. Early on, giant planets interacted with a disk of smaller bodies. Orbits shifted, resonances moved, bodies scattered. In many models, the outer solar system went through a phase of instability where planets migrated and swapped energy with countless icy planetesimals. Uranus almost certainly took part in that story, and it might have taken a hit during it. The sideways tilt is the obvious scar, but the quieter scar might be the interior layering that traps heat. If a giant impact knocked Uranus over, it could also have altered how the interior mixed, creating stable layers that suppress convection and keep internal warmth from escaping efficiently. That would change the entire planet's long-term evolution. Less heat leaking out means a calmer-looking atmosphere, fewer obvious convection-driven storms, and a planet that feels more muted compared to Neptune. If that's true, Uranus becomes an example of something the universe probably does all the time. A planet's present-day personality depends on accidents of early history. The same basic ingredients can produce very different outcomes depending on collisions, migration paths, and mixing. That's a scary thought if you like simple categories, but it's a calming thought if you like realism, because it means the universe isn't trying to make everything predictable. It's making stable outcomes from messy beginnings. And Uranus is one of those stable outcomes, a planet that took a weird configuration and turned it into routine. That's why Uranus feels so quiet now, not because it's boring, but because it's settled. It's the calm after early chaos, stretched out over billions of years. Even the way Uranus changes is slow and steady rather than loud. The planet's appearance can shift with season, polar brightening, haze changes, cloud activity becoming more visible at different phases of the orbit. but those are long, gentle transitions. Uranus doesn't do constant fireworks. It does long moods, and those moods matter because they remind you how different a climate system can be when sunlight distribution is extreme and timescales are enormous. On Earth, you can feel a season change in weeks. On Uranus, the planet itself spends years slowly leaning into a new lighting setup. Imagine an atmosphere being photochemically processed under weak sunlight for a decade straight in one hemisphere. Imagine the opposite hemisphere spending a decade in darkness, chemistry shifting differently, temperatures evolving differently, hazes thinning or thickening in a different pattern. Then imagine the planet drifting toward equinox and forcing the atmosphere to rebalance, to mix, to adjust circulation. That's not a quick storm story. That's a slow planet story. A slow planet story is exactly what most people don't know how to sit with, which is why Uranus gets mislabeled. Now add the rings and moons, because they're not just decorations, they're part of how you read a planet's environment. Uranus is thin, dark rings are narrow and disciplined, likely confined by gravitational interactions. The moons orbit with poetic names, but their surfaces are records of stress, impacts, and ancient activity, especially Miranda's fractured patchwork terrain that looks like the aftermath of internal strain and resurfacing. If you had an orbiter, you could watch these systems properly. You could map the ring's fine structure, identify shepherding relationships, track dust sources, and see how charged particles and electromagnetic forces influence tiny grains. You could map moons in high resolution, read their tectonics, and test whether any hints of subsurface layering or ancient heating patterns exist. You could do gravity science not only on the planet, but potentially in flybys that reveal mass distributions and internal structures. You could connect the planet's magnetic environment to auroral behavior and upper atmosphere chemistry. You could finally stop guessing. That's what makes Uranus important in a way that's almost embarrassing. It's one of the biggest planets we've barely studied, and it might be the best local laboratory we have for understanding a whole class of common exoplanets. So if you're listening to this at night, the calm way to hold Part 14 is to let Uranus become a symbol of scale and patience. A world that isn't here to entertain you. A world that doesn't change on your schedule. A world that has reasons for everything. But the reasons live deep inside, and you only uncover them by staying close and watching long enough. Picture Uranus as a pale, sideways planet under a small, distant sun, its hazes softening its face, its winds sliding quietly around the globe, its long seasons shifting the chemistry over decades, its internal heat held deep behind stable layers, its crooked magnetic field sweeping space in a lopsided rhythm, its thin dark rings holding their narrow lanes, and its moons circling like quiet witnesses. Then zoom out, farther, beyond the solar system, and imagine countless distant stars with planets in that same size class, Uranus-sized, Neptune-sized worlds we detect as tiny dips in starlight, worlds we can barely taste through spectroscopy, worlds we label quickly because we want categories. Uranus is the reminder that the category isn't enough. The details matter, history matters, structure matters, time matters. And the best part is, you don't have to solve it tonight. You can let Uranus be what it is, a quiet planet that teaches patience, and a quiet planet that proves weirdness can become stable, and a quiet planet that keeps rolling on its side without apology, as if to say the simplest rule of the universe is not be normal, it's be consistent. And if your thoughts are still buzzing, borrow that rule. Don't force normal, just drift toward consistency. Slow down, let the noise fade, let the long rhythms take over. Uranus has been doing that for billions of years, and it's not in a hurry. Neither do you have to be. Uranus doesn't need a dramatic ending, because the whole point of Uranus is that the drama happened a long time ago, and what's left is the calm aftermath stretched across billions of years. If you zoom out and look at the solar system like a story, Uranus is the chapter people skip because it doesn't scream for attention, and that's exactly why it matters. Uranus is a planet that forces you to stop expecting the universe to behave in neat, familiar patterns. It's an ice giant that looks gentle from far away, pale blue-green, soft contrast, often smooth-looking, yet nearly everything about its setup is extreme. Start with the simplest image, the one that reshapes everything else. Uranus rolling around the sun on its side. It's not a cute tilt, not a little lean, but a posture so off-balance that it turns seasons into eras. Uranus still spins with a short day, but its year is about 84 Earth years, and with that sideways axis, the sunlight doesn't fall the way your brain wants it to. For long stretches, one hemisphere is tipped toward the sun while the other is tipped away, and near the poles that becomes something wild in the quietest way. Long years of weak, continuous daylight on one side, and long years of darkness on the other. Then a slow exchange that doesn't feel like a switch. It feels like a tide you only notice after it's already shifted. That alone makes Uranus feel like a different kind of world clock, one where change happens on a schedule too slow for human impatience. And because it's far away, the sun out there isn't warm in the emotional sense. It's small, bright but distant, like a lamp across a huge room. That distance is why Uranus can look cold and calm even when it's moving, and it's also why people misread it. They see a smooth disk and assume there's nothing going on. That assumption is trash. Uranus has weather, Uranus has winds, Uranus has clouds. It just doesn't always show them with high contrast, because its atmosphere is a veil. Methane helps give the planet its blue-green color by absorbing red light, but haze layers in the upper atmosphere can soften everything, flattening detail the way thin fog flattens a city skyline. When Uranus does decide to show you something, it shows you bright methane ice clouds and subtle banding and occasional storm systems that flare up and fade, like the planet briefly pulls back the curtain and then closes it again. And those changes aren't random. They may be tied to Uranus's long seasonal forcing. As Uranus moves through its orbit and the sunlight distribution shifts, the planet's chemistry and circulation can reorganize slowly. The upper atmosphere can be photochemically processed differently, depending on how long it sits under weak sunlight or long darkness, and that can change haze thickness and brightness patterns, especially toward the poles. This is one of Uranus's most important lessons. Visibility isn't activity. If you don't see the storm, it doesn't mean the planet is asleep. It might mean you're looking at the wrong time in the wrong season through the wrong haze. The planet's time scale is longer than your patience, and that's why it stays misunderstood. Then you hit the deeper truth that makes Uranus feel like a planet with something held back. The heat problem. Neptune, similar in size and category, leaks internal heat strongly. It radiates more energy than it receives from the sun, and that extra energy helps drive dramatic convection and obvious storms. Uranus doesn't seem to do that in the same way. Uranus emits far less excess heat, and that's not a tiny detail. That's a sign that the interior may be structured differently. The leading idea is stratification. Uranus could have layers arranged by composition in a stable way that suppresses convection, meaning heat exists but doesn't travel upward efficiently. In a normal convecting planet, warm material rises and cool sinks, and over time, the planet leaks its internal energy. If Uranus is layered in a way that resists mixing, the deep warmth can be trapped. It becomes a planet that isn't dead, but contained. That containment could shape the whole personality. Less internal energy reaching the outer atmosphere means less constant storminess, more muted expression, a world that can still move and change, but doesn't constantly advertise it. This restraint is what makes Uranus feel calm to think about at night. A planet with a deep engine that doesn't shout, a planet that holds on to its warmth like a secret instead of throwing it into space. And then the magnetic field comes in and proves again that Uranus's weirdness is structural, not cosmetic. Uranus has a magnetic field that is strongly tilted relative to its rotation axis and offset from the planet's center. That lopsided geometry implies the dynamo isn't a neat, centered molten metal core like Earth's. In ice giants, the dynamo likely lives in a conducting layer within the mantle, where pressure turns ices like water and ammonia mixtures into hot, dense, electrically conductive fluids. If that conducting region is shell-like and not symmetric, the field comes out crooked. And because Uranus is already sideways, the magnetosphere becomes even more absurd. It doesn't meet the solar wind in one stable orientation. As Uranus rotates, the magnetic field swings around like a crooked lantern. As Uranus crawls through its long orbit, the overall orientation relative to the Sun changes drastically across decades. The space around Uranus isn't empty peace. It's a dynamic electromagnetic environment with trapped particles, shifting field lines, potential auroral activity, and a geometry that never lines up neatly. It's invisible motion layered over visible motion, and it's the same story again. Uranus is active in ways you don't automatically see. Then the rings and moons echo the same personality, but in physical form. Uranus has rings, but they're thin, dark, narrow, and disciplined, not bright theatrical sheets like Saturn's. They were discovered by watching starlight blink during an occultation, which is exactly how Uranus likes to reveal itself. Through subtle evidence rather than loud display. Narrow rings don't stay narrow by accident. Collisions should spread ring material out over time unless something keeps edges confined. That something is gravity and resonance and shepherding, small moons or moonlets nudging particles back into place repeatedly until structure holds. Uranus's ring system is quiet geometry, maintained by repetition. Beyond the rings, Uranus carries moons with literary names: Miranda, Ariel, Umbriel, Titania, Oberon, names that sound gentle, but the surfaces are anything but. Miranda especially looks like a small world that went through brutal stress. Patchwork terrain, massive cliffs, strange features that hint at ancient heating, orbital, resonances, tectonic strain, maybe catastrophic impacts, and then a long cooling. Ariel shows signs of resurfacing, suggesting it wasn't always inert. The larger moons carry scars and fractures that read like slow histories written in ice and rock. These moons aren't decorative. They're records of what the Uranian system has survived. And all of it points back to the same underlying suspicion. Something major happened early on. The sideways tilt is the obvious scar, and a giant impact is a strong candidate for what knocked Uranus over. If that happened, it wouldn't just tilt the planet. It could have rearranged the interior, possibly creating the layered structure that traps heat and shapes the planet's muted behavior. That's why Uranus feels like a world that experienced ancient violence, but expresses it as quiet stability now. It's the calm after chaos stretched across geological time. Uranus is weird, yes, but it's weird in a stable way. It's not wobbling wildly. It's not falling apart. It's been rolling like this for billions of years, letting long seasons sweep slowly across it, letting hazes build and thin, letting clouds form and fade, letting winds slide in broad currents beneath a soft veil, letting its crooked magnetic engine sweep space in patterns no one can see from Earth without instruments, letting rings stay confined by repeated gravitational corrections, letting moons circle like quiet witnesses. That stability is the part to steal when you're trying to sleep, because it makes your own urgency feel stupid in comparison. Uranus doesn't hurry. Uranus doesn't need to be understood tonight. Uranus doesn't need to prove itself. It continues whether anyone pays attention or not. And if you pull that idea into your own head for a minute, it starts to loosen things. Your thoughts are loud because you treat them like emergencies. Uranus is the opposite. Everything there is extreme, and nothing is urgent. The planet's light. Cycles move over decades. Its atmospheric shifts can take years. Its interior evolution happens over billions of years. It's a world where the right response isn't panic or obsession, it's patience. And that patience is calming because it reduces your mental scale. If Uranus can carry a sideways tilt for billions of years and still function as a coherent system, with rings, moons, winds, magnetosphere, then your brain can survive letting go for one night. You don't have to solve your day right now. You don't have to replay every moment. You don't have to force your thoughts into alignment. Uranus didn't align itself back into a neat axis. It adapted to a new posture and kept going. That's the real closing message. Stability doesn't require normal. Uranus is a planet that never returned to the expected configuration. And yet it became consistent, predictable in its own strange way, a world that built a routine around being off-kilter. So let the last image be, clean and slow. Uranus far away under a small sun, pale blue-green in the dark, rolling on its side through an 84-year orbit, decades of light and darkness trading places like tides, hazes drifting softly across the upper atmosphere, occasional bright clouds forming like quiet breaths, wind sliding in broad bands around the globe, deep layers compressing matter into hot, dense fluids, an off-center dynamo generating a tilted magnetic field that wobbles through space, thin dark rings holding narrow lanes, moons orbiting with gentle names and rough scars, everything moving without noise, everything continuing without demand, nothing in a rush, nothing asking for attention, just a stable, strange world doing what it does, repeating its long rhythms until your thoughts finally copy those rhythms, slower, softer, quieter, until the need to keep thinking breaks apart and you let the night take the rest.